Okay, now let us understand vector addition of two vectors by triangle law. Suppose this is an object and two vectors are acting on the object simultaneously. This is a vector P in this direction and another vector Q in this direction. The length of the arrow will be the magnitude of the vector. Yes. So if I want to find out the resultant of the two vectors, now these two vectors may be force vectors. So if I want to find out the resultant, that means a single vector that will do the work of both of them together. That is nothing but the resultant vector. So how is that done? We have to parallelly shift the vectors because that is allowed, because parallelly shifting the vectors does not change the direction as well as the magnitude. Hmm. So in a vector, this part will be called as the head and this part will be called as the tail of the vector. So what we have to do in order to find out the resultant, we have to take the tail of one vector and put it on the head of the second vector. So in order to parallel shift Q, I will have to parallelly shift Q such that its tail is on the head of P. Okay, so this is how it is done. So the resultant will be given by the third side that will complete the triangle. Okay, so how to complete the triangle? We have to draw a vector joining the tail of the first to the head of the second. So this will be the resultant in magnitude as well as direction. So if I parallel shift the resultant over here, it will be like this. So the magnitude of this R will be given by the length of this arrow and the direction is as shown by R. One interesting thing to understand the triangle law is from this example. Suppose I have a wooden plank like this, and suppose this is point A on the plank and this is point B on the plank. The distance A to B is of, let us say, 4 meters. We have an object placed on E. In first scenario, let us say the object goes from A to B, that is covering a distance of 4 meter in 1 second. Now in the second scenario, let us say the plank itself is being lifted up by distance 3 meters. So where the object will go? It will go up the distance of 3 meters. This is 3 meters. Now imagine that both the things have happened simultaneously. The object also goes along the plank a distance of 4 meter in 1 second, and the plank is also getting lifted up by a distance of 3 meter in the same time, 1 second. So now if you think the object, where will the object now be? It will travel like this, right? And reach this point B over here. So basically what has happened, the two vectors has been added. One vector simultaneously. One vector towards right of 4 meters, displacement vector, and another displacement vector upwards of 3 meters. So the resultant will be a slant vector, right? The object will follow a slant distance. So now it is quite easy. How much will be this distance? This distance will be nothing but 5 meter, correct? Because if I draw a triangle, this side was 4 meter, this vertical side was 3 meter, so the hypotenuse has to be, from Pythagoras theorem, it will be 5. So see, how does the triangle law over here help? So I have to draw two vectors, one of 4 meter vector in this direction, the length, uh, let us say it is denoting of 4 meters, and another vector I have to join tail of the second to head of the first, right? So this should be of 3 meter. So in order to find the resultant, I have to draw a third vector starting from the tail of the first to the head of the second to complete the triangle. So this is nothing but the resultant. And as you can see, the resultant is nothing but of 5 meter. So this is how the triangle of vector addition works. It not only works for just the displacement, but for all vectors. Even the force vectors will be added by the same triangle or any other two vectors.